This video is to go over the Richter scale, one of the applications of logarithms that I look at in North Carolina Math 4. So in 1935, the American geologist Charles Richter defined the magnitude m of an earthquake to be equal to the common log of the earthquake's intensity divided by what we call a standard intensity on a seismograph. On a seismograph. So when we take the magnitude, we're going to take the common log of what the intensity was, and it's supposed to be measured 100 kilometers from the epicenter of the earthquake on the seismograph, and then compare it to this standard intensity. And the main application that I teach in Math 4 is to find the difference in the intensities of two earthquakes. Like how many more times intense was, say, the bigger earthquake than the smaller earthquake. So let's take a look at an example. The 1906 earthquake in San Francisco had an estimated magnitude of 8.3 on the Richter scale. During Game 3 of the 1989 World Series, San Francisco was shaken by an earthquake measuring 7.1 on the Richter scale. How many times more intense was the 1906 earthquake than the 1989 event? So what we're doing here is we're looking to see how many times more intense was the earthquake in 1906 than the one in 1989. They're both fairly large on the Richter scale. But what we have to remember is the Richter scale, a difference in one magnitude is actually a difference of times 10 in intensity because it is a logarithmic scale. So what it's asking for here is, and I'm going to go ahead and open a new document because we're not going to have room to complete this all on those slides. So if I want to compare these two, what I'm going to need to do is first, basically what it's asking is to find the difference in the intensities, or the difference, if you will, in the magnitudes. So the one in 1906 was 8.3, and the one in 1989 was 7.1. Now, if I apply my formula to this, and let's say I call this earthquake number, let's say we call the 1906 earthquake number 1. And this is going to come in important in a second because I'm going to use a subscript. And we'll call the 1989 earthquake number 2. Then I'm going to basically use my formula twice with a difference in between it. So I'm going to say the common log of the intensity of earthquake number 1 divided by the standard earthquake minus the common log of the intensity of earthquake number 2, that is the 1989 earthquake, divided by the standard intensity. Now, with our property of logarithms, there we have a property. We have the quotient property, which says because I have these two logarithms at the same base, and I'm taking a difference between the two of them, I can always rewrite these as a single logarithm. So this is going to be the common log of, and now I'm going to have this measurement for the first earthquake, I1 divided by S, that standard intensity. That is going to get divided by the intensity of earthquake 2 divided by the standard intensity. Now, so essentially we have a fraction divided by a fraction. So if you recall division of fractions, the idea is I'm going to actually turn this into multiplication. And so I'm going to have that first intensity of the first earthquake, that is the 1906 earthquake, divided by the standard intensity, but then I need to multiply by the reciprocal of the denominator that I just had. So we're going to say the standard earthquake intensity 2 And so once I do this and I simplify this, the standard intensities are going to simplify out, and I'm going to be left with the common log of intensity 1 divided by intensity 2, which is what I want because this is comparing my two intensities. All right, this is comparing my two intensities. So essentially what we have at this point is we have that 8.3 for the 1906 earthquake minus the 7.1 in 1989 is equal to the common log of the comparison of their intensities. And this comparison of intensities is what the problem's actually asking about. It wants to know, what is this comparison right here? How many more times? Because this is going to tell us, if I take the intensity of the first earthquake divided by the intensity of the second earthquake, that's going to tell me how many more times intense the 1906 was versus the 1989. So now that I have it as an isolated logarithm, my job now is going to be to rewrite it as an exponential equation. So it's the common logarithm, so our base here is going to be 10. The logarithm is equal to the exponent, so I'm going to take 8.3 minus 7.1, so essentially the difference between the magnitudes of the two earthquakes. And this is going to give us the intensity of the 1906 earthquake divided by the intensity of the 1989 earthquake, which is going to give us that difference in intensity. How many more times intense, if you will. So now I'm just going to go to the calculator and I'm going to say I need to find 10 raised to 8.3 minus 7.1. And so we come up with about 15.8. And so this turns out to be about 15.8. And so what that means, so going back to the question, so this is the work for it. If I come back to this question here, we now know that the 1906 earthquake was about 15.8 times as intense as the 1989 earthquake. And that's it. You can find the difference in intensity, or how many more times intense one earthquake is than another, using this formula for the Richter scale and the work that I just presented to you.